So to actually simplify the difference quotient, this is something that you'll see in the homework. It'll say simplify the difference quotient or something along those lines. What you want to just do is start with the generic algebraic difference quotient f of x plus h minus f of x divided by h. And basically, instead of plugging numbers in, just plug the algebraic expressions into your function. And how your homework will recommend to do is start with figuring out what is f of x plus h. Because from there, then you need to take away f of x and divide by h. But starting with f of x plus h, our original function was f of x is equal to x minus 3 squared. So x plus h would just mean, well, instead of plugging in x, I'm going to change this to x plus h, so this would also change to x plus h. So that would be x plus h minus 3 quantity squared. And here, this is going to be not so pretty because if you recall, when I have a parenthesis something squared, that means, well, really, I gotta have to take this whole thing and multiply it by itself. You can't just square those individual parts. That's not how algebra works, and that's a very common mistake. And in my experience, the reason people get messed up in calculus is not because of the concepts, it's often just the understanding of algebra. So it's kind of a reminder on how to do algebra here. But basically, I needed to FOIL all of this out to figure out f of x plus h. Now, since I have 3 terms times 3 terms, I'm actually going to get a product of 9 total things, but let's just start distributing. So I would get x squared plus xh minus 3x from the first FOIL. Then I would get hx, or I'll write it in the same way, xh. Then I would have h times h, which is plus h squared. And then I would have h times negative 3. And last but not least, I can't forget to also distribute the negative 3. Remember that negatives distribute with the term. So negative 3 times x would be minus 3x. Then I have minus 3 times h. And then minus 3 times minus 3 would be plus 9. And that would be the expansion of this trinomial squared. Now, I can simplify this by combining like terms. Again, more algebra. But x squared is the only one, so there's nothing alike with that. We have 2 different xh terms. We have minus 3x minus another 3x, which would be minus 6x. We have an h squared all by itself. We have minus 3h minus another 3h, that would be minus 6h, and then we have plus 9. And none of those other terms are alike, so that is as far as we can simplify. So long story short, we can come up with f of x plus h. It is this big thing. And again, I want to substitute that in there if I wanted to actually simplify and solve the difference quotient. I tried to not give you too many of these problems in your homework because they are quite long and filled with lots of algebra. So anyways, f of x plus h is x squared plus 2xh minus 6x plus h squared minus 6h plus 9. And that is all. We still have to subtract f of x, and we still need to subtract, or we need to divide it all by h. So I'm going to go ahead and use parentheses. The first thing I recommend doing every time you're doing the difference quotient is automatically putting parentheses around your function. Because another very, very common mistake I've seen with my students' work is losing negatives or missing out on the subtraction. Because if we're taking a function minus another function, there's always implied parentheses there. Basically, I need to take this whole function and subtract the whole other function, which is just f of x. So f of x was the original function. It will actually help if I FOIL this one out as well, because the original function, f of x, was equal to x minus 3 squared. Well, again, it might help to write that out as a full polynomial. So that would be x squared minus 6x plus 9. There's a shortcut for expanding this squared, which is, I'll go ahead and, if you've never seen this shortcut before, it's kind of nice. What you can always do is you're going to square the first term, you're going to multiply the 2 inside together times 2, which would give us minus 6x, and you would square the last term. That's how I did that so fast. But of course, you can always just FOIL it out, and you'll see you should get the same thing. But essentially, f of x, that's the second component here of my difference quotient. I'll go ahead and underline that in blue. And that is what I just figured out up here, right there. And I was just running a little low on space in my notes. So, and again, I want to make sure that that goes there. And then the green part was from the f of x plus h. That was all went right there. Okay, so f of x was x squared minus 6x plus 9. And now, and this is how the difference quotient will always go, or in most contexts, we want to figure out what will cancel, what will simplify, if anything. Because basically what f of x plus h and f of x do, they create these big old giant polynomials, or whatever the functions are, expressions involving x's and h's. Now, when I subtract them though, they actually, a lot of stuff should always cancel. And that, even though this looks really, really horribly daunting, at the end of the day, usually we'll get a fairly simple answer from this. And the answer is what we care about, which is what's the simplification of the difference quotient. But here, notice that we have an x squared. Let's go ahead and just, but really, since this all is going to be subtracted, the negative will distribute. So let's actually just do that. I don't want to rewrite it though, so I'm just going to distribute the negative to each term without rewriting it. But basically, this would be a negative times a positive. This one will stay negative. This would be negative times negative. This one will swap to a positive, and negative times positive will switch to a negative. So what you could just remember is that when you're subtracting f of x, you want to make sure that you change all the signs. Minus x squared plus 6x minus 9. And so I'll go ahead and just write it like this. Plus and minus. So, because when you're taking away a function, all the signs will change. Now, I could cancel out the common terms, because in the numerator, notice, well, I have x squared and minus x squared. Those are common terms. They're the same but opposite. So those would cancel out to make 0. I also have a negative 6x and a plus 6x. Those also cancel. And what you'll see is most of the time with a lot of functions, f of x will completely cancel with f of x plus h, but it will leave some other stuff left over. That's what we end up caring about. And then we have a plus 9 and a minus 9, which also cancel. So at the end of the day, what we are left with is 2xh plus h squared minus 6h all divided by h. And from here, we're still not done, but we have greatly simplified the difference quotient, which started off pretty horribly. So let me erase some of this to give myself some more room. Sorry, the notes are getting a little hectic. I didn't really give us enough space to do this, did I? On your packet. But notice now I have all this and I need to divide it by h. So reminder that a common mistake I've seen here is students will just cancel out an h like that. But remember, if you're going to divide by h, you need to, in a fraction, it means the entire thing is divided by h. You can't just simply cancel h like this. This is improper algebra. That's not really correct. So one way you could do this is by dividing each term by h. That is fine. Or more of a common algebraic approach would be, well, notice that the numerator has a common factor of h. You could actually factor out h from the numerator, which would leave us, because it's a GCF, which would leave us with 2x plus h minus 6, right? Because I could pull out that h from each term by the reverse distributive property, aka factoring the greatest common factor. But basically I could factor out that common h, and now the h would cancel only after factoring. So a reminder about this sort of fraction math with algebra, always factor before you try to cancel. You can't cancel between individual terms. You can only cancel if the top and the bottom are factored properly. So anyways, what that leaves me with is 2x plus h minus 6. And that is as simple as we can get for our difference quotient. Or another way of approaching this is you could just divide each by h, because 2xh divided by h, this h would cancel. H squared over h would leave me with h, and negative 6h divided by h would just leave me with minus 6. So before I wrap up this video, what is the point of all this? Again, you'll see very soon in class this week, we'll talk a lot more about how to use the difference quotient and so forth. But the point of simplifying the difference quotient is it started off as this really, really horrible chain of mathematics. This is a much simpler process, and technically this is equal to this original expression here. And you can actually use this to do these same calculations. So if you remember how I was calculating using the difference quotient before, I was doing it by using the original mathematics. But basically, this is an equivalent expression to all of this. So we could have calculated the difference quotient using this new fangled fancy formula 2x plus h minus 6. So let's just do it and you'll see what I mean. So instead, we could use 2x plus h minus 6. So here, x was 1 and h was 2. So we'd have 2 times 1 plus h, which is 2, minus 6. And this should give us the requisite answer. Notice that that gives me 4 minus 6, which is negative 2. Uncoincidentally, it's the same answer, but if you can probably agree, the math is way easier than having to have done all of that before. Still don't believe me this will work? Let's try a couple more. So basically, let's try using 2x plus h minus 6. So I have 2x, which is 2 times 1, minus h, or sorry, plus h, which is 1 as well. 2x plus h, again, it might help if I write this over here. This is the simplified difference quotient for this function. And every function will have its own difference quotient, and it will all simplify differently, but this is the value of the difference quotient for evaluating positions and calculating average slopes. And then, of course, minus 6. Notice that gives me 3 minus 6, negative 3. Again, as you can agree, way simpler math than having to do all this. Let's do one more, and then we will wrap up the video. So here I would have, well, again, it's 2x. 2 times 1 is 2, plus h, plus 0.1, minus 6 would give me my slope. 2.1 minus 6 would be negative 3.9. Again, consistent. And we could analyze this difference quotient. So sort of summarizing, the point of this is we create a simpler expression which describes the slope for this function. It's unique to the function. Every function will have its own unique difference quotient. And simplifying it algebraically helps us study what happens to the slope at particular points in time. And there's a few more practice problems below. Try them for yourself. These get quite a bit harder when the algebra is harder. We'll continue working on these as we go for the next week in class.